Hi girls, so I hope you've already watched the video that I linked to on our portal page. If you haven't, please go and do that first. It's only a minute and it will just give you a better visual than I'm able to draw on this. And then if you come back and look at this, and I'm doing something very similar to that problem here. So the problem is that y equals 2x, the curve is rotated about the x-axis, and I've got some bounds for x, and I'm asked to find the volume. So first thing, as always, is I draw a diagram. So here's my curve. Try again. Okay, I'm just going to pretend that's right. Y equals 2x between 0 and 3. So I'm just rotating this region here, and I'm rotating it about the x-axis. Okay? So this thing is going to spin this way when I rotate it, and it's going to create a volume like the front of a trumpet, for example. Okay. The important thing to notice is, as I'm drawing these volume revolutions in, you can hopefully see that they are circles, and that they are circles with thickness that I'm going to call dx, in exactly the same way that I did for area. When I drew a rectangle, it had thickness dx. When I do a circle rotated about the x-axis, I get the x. Okay, that's the important thing to remember. And then here is the center. So the radius of the circle is all I need to find its area. And the radius equals y. Yeah, the y here, for a fixed value of x, y is the radius. So the area of that circle there, the volume of that circular like coin shape is pi times the radius squared times the thickness. And so what we're going to do is exactly like before. We're going to take a big sum, which turns out to be an integral of all of the individual coins with the limits of x, right? The limits on my integral, these numbers, should always match whatever letter that is, being in x's. So the question, it was 0 to 3. Oops, sorry. Oh no, there we go. 0 to 3, so I put those on there. And now it's a matter of doing integration. Now I can't integrate until the y's and the x match the x, so I have to replace x's with y's, and also I can always pull a constant out the front of an integral, and pi is just a number, it's just a constant. So y is 2x, so y squared is 4x squared. And now it's exactly the same as every other integration we've ever done. So it's pi 4x cubed divided by 3 between 3 and 0. I'll just move over to the left, which equals 4 nines are 36 pi units cubed. Okay. So if I asked exactly the same problem, a very similar problem, and I'll just do it in shorthand. So let's say it's y equals x squared, 0, y, 3, around the y-axis. So I could draw a diagram again. So something like that, with the cutoff at 3, goes that way. And then if I imagine the shape, it goes that way, because I'm rotating about the y-axis. And again, I get a circle. This time the thickness is in terms of y, because it's on the y-axis, it's dy. I rotate it about the y-axis, so I get dy, and the radius is x. So the volume is going to equal limits in y, area of the circle, dy. Oops, sorry, dy. And then I replace x to match y because I've got dy, and I'll just cheat. Look at that. which I know how to integrate easily. That's all you need to be able to do. It's actually really quite an easy topic. Okay, so again, I'll give you some notes to write down tomorrow and we'll do some practice, but hopefully that makes a little bit of sense. Okay, thanks girls, I'll see you tomorrow.